just coming back from a snow day. I said this to my Business 101 students. By the way, for show of hands here, how many of you have actually ever had a snow day at St. Francis before? What benefited you? We actually have a snow day that benefited you. Like I told the freshmen in Biz 101, they should mark this down because it'll be something they're telling their grandkids about that St. Francis actually canceled classes. So it's pretty amazing. Guys, because of that, we're not really behind because I was planning on showing you a documentary that day anyway because I was going to be in a campus meeting. As it turns out, I'm still going to be in a campus meeting that got rescheduled for the 19th. As such, we're going to be doing our first test in this class on the 19th. Now, some of you are affected by some other scheduling involving Enactus. I'll talk with you guys after class about. We'll figure that out. But guys, the tests in my class are nothing to fear. Multiple choice, true and false, not too bad. If you've been keeping up with conversation in class, if you've been taking notes, if you've been reading the slides, reading the text, you're going to be fine. And we're going to review. So once we get through chapter 3, we're going to have our first exam in here. And no assignment due for this particular chapter. However, the assignment that was due on Friday is now overdue. I'm giving you a grace period till the end of today to get it submitted without penalty. So please get that in. Now, I heard a few folks talking on the way in today about keys. If you don't mind me putting you guys on the spot, what was your conversation about keys? Because it ties into something we're going to talk about at the beginning of the class.
It started off with being locked out of our actual houses where we lived. They kind of transformed into like dorm rooms. Like how we locked ourselves out of dorm rooms, like the whole dorm in general.
Okay. Does anybody here ever lock themselves out of their car? That's a bad experience too, right? So, guys, Apple and a couple other companies want to help you here. And what just came out the last couple of days, Apple essentially is going to be enabling in their next version of operating systems a digital key. What the thought is cars now that are equipped with Apple Play, and this is done in conjunction with a consortium of companies, including Google, who are doing different types of automotive software, that we may end up using our smartphones as our car keys. I have a brief video to show you guys, and we're going to talk about it before we get back into the world of IP networking today. So sit back and enjoy. Exciting news that I don't have a video to show you yet is the new version of iOS 13, which comes out this week, is going to be enabled with code essentially to allow you to use it as a key. The way this is going to work, a couple of manufacturers, including Google and other folks who are writing third-party apps for both Apple and for Android phones, essentially are trying to come up with a standard where essentially you can use a device to use as your car key. How many of you have keyless key fobs in your cars now? Same concept, except your smart phone would take the place of that fob. How is this important, guys? Yeah, Hunter, go ahead.
It again utilizes that idea of like you don't like because you like technically like right now if you wanted to, you don't need to carry a wallet, you don't need to carry rewards cards, you don't need to carry like everything is being stored on your phone, which means it's kind of making the high prices of smartphones more justifiable because you're able to lessen the amount of things you need to carry. So because you can keep your debit and credit cards on there, Venmo's on your phone. I know for me, like my Sheets card is on my phone in case I don't have my keys with me. I can always like get that scanned. Like, a lot of companies are making it so you don't have to have a physical item with you, which will in turn also make it like if they wanted to, they could make it so like this new phone will have this, and then it also is a way to justify getting a new phone or that selling one. So it's really using things to simplify.
Yeah, it's further centralizing everything on our phone. I completely agree. And as far as like justifying the price of a phone, what is the average price for a new smartphone when you're starting a basic plan at this point? $700 to $1,000 to $1,100, depending on what you're buying. So that's not insubstantial. What are other potential impacts of this move by Apple? Any other thoughts? Yes.
I have a question about the CarPlay.
Yeah.
So that was when that video was put on 2013, 2014.
Yeah, that was old.
So is that like advanced at all? Like, I haven't heard anything about it. Is it use it still?
Oh yeah. In fact, a lot of companies these days, for example, whether you're talking Mazda, Toyota, GM, they're offering both Android Auto and Apple CarPlay, for example. But at this point in time, back when the video came out, the video was contextual. But back when that video came out, for example, we weren't actually using these as key fobs. Here's another potential thought. Let's say, for example, Adam wants to lend me his car for the weekend. Would you lend me your car, by the way, if I asked you, would you lend me your car? Sure. I bring it back with a full tank of gas. I'd be responsible. Is it a stick? Yeah, I can drive a stick, so it's perfect. But the idea being, if he would unlock his car, basically the idea being I would have access to his vehicle based on his permission, because it's some central repository using some central type of logon. He's giving me permission to use his car. Think about this for things like rental services. You get into the airport, you go to get your rental car, you're not even stopping at a desk anymore. I mean, we don't have to now already with some of the services that are out there. But I could literally say, my car is in spot A14. I'm going to walk there with my phone, enable myself to get into the car, and off I go. Are there other reasons why companies might be interested in this kind of a technology? Yes.
That's more like they have the potential to collect more data. So if they know like when you're, I don't know, just going places even when you're using your car, it's just like another aspect that they can collect information on.
Absolutely, yes.
I think like it's also another thing they can charge more money for. Like they can, I mean, it's something that they don't like. It's a software element. Like you probably have to adapt a few things, but it's probably not anything major that they have to change, especially if your car already has like remote start and stuff like that, which most vehicles come with.
Yep.
So it's another feature that they can charge more money for. Like on the lower end models, it doesn't have it. On the higher end models, it does. So that can be an incentive. Because like I know with me, even like I just have like keyless entry, like with my fob, like I click the side buttons. Like whenever I switch over to one of my dad's truck doesn't have keyless entry, so like it's always like he's not hitting the unlock button, and like it's not that big of an inconvenience, but it's like still like an extra thing you have to grab, or it's nice like if they're just in your bag, you don't have to like roof or stuff. So if you just have your phone with you, you don't, you might not even have to unlock it. It just know, like as I know my mom's car, as long as you're in proximity and you pull on the handle, it'll open. So like same with the phone. So it's just a way to lessen, like with everything we carry, it's a way to lessen that.
Even the old ignitions are starting to seem primitive, So we got the premium aspect. What about in terms of this consumer tracking? How might this work? Yes.
Since CarPlay links with maps and all that, but we always see where you frequent, where like if you're going past this coffee shop frequently, it can suggest that as a place to get breakfast or coffee on your way to work. Companies could pay to have, like if it sees your route and it sees that you frequently stop to get coffee, they could pay to have their coffee shop rank like suggested or ranked higher than Dunkin'.
Right. I think that's absolutely correct. So say, for example, if Starbucks has a relationship with Enterprise Rent-A-Car, for example, they could be incentivizing you to go there instead. Is there another way that this information could be used? We're already, yes. Yeah, tell me more.
You can be able to compare like if two people are going to the same place, who got there faster, how they do it, like a matter of like what route they took, and from that maybe it would determine what the absolute best route is for them.
Especially if you're using something like Google Maps or Waze. By show of hands, how many of you use your phone for some kind of mobile payment? Check it out, guys. We're always giving up location data when we use these things. So let's say, for example, I'm using the rental car, or I'm using Adam's car because Adam's lending me his car. Well, the car is all of a sudden seeing the last 4 transactions that you made using, I don't know, Apple Pay or gift cards. You were buying stuff at Popeyes, or you were buying, you're out for lunch with Dr. Fry. You went to Popeyes 4 times last week. Well, it's true. It's only funny because it's true. But the idea being that we'll incentivize Tonkin to go back there, or give him coupons there because he already eats there anyway. So not only can they make directions for us, but also actively mine information off of our phones while we're in these vehicles. I think this is like, when we talk about things that are seismic, we talk about things that are game changers, this is a big one. And I think for some of the reasons that have already been outlined, the idea that our phones are so part and parcel to our daily lives, this is really taking it to the next level, because think of how much we rely on our cars, particularly in the United States where public transit is really so bad for most of us. This is pretty seismic, I think. Any other thoughts before we move on? What do you guys think about this? How many of you, by show of hands, would feel comfortable using your phone as your car key? How many of you are on the fence? Can I put one of you on the spot? Well, somebody tell me why you're on the fence about it. Yes. Yeah, that's true too. I mean, although I can say if I had to give you my stress levels, losing my phone versus losing my car keys, I think I'd be a little more stressed about losing my phone for sure. Yeah, I think that people are that's just one more thing you have to worry about. Yes.
Well, I guess you can lose one or the other, which is like safer. I guess like the more things you have, the safer it is. If you encompass everything in one item like your phone, then suddenly if you lose your phone, you didn't just lose your phone. You might have lost your car. You might have lost like, all these accounts. So
Although, in network security, there are two competing philosophies of complexity versus fortification of a single exit. So the idea being, if you've got a castle, it's got one door, you just put all your armor in front of that door. If you got multiple doors, you've got smaller doors to defend. Interesting. Yes.
I think like on the like if you while it's not guaranteed, there is a slight unless you have like a tile, you are like not always, but frequently able to find my iPhone or whatever. I know there's an equivalent for like Samsung and Android phones. So like there's still like a level of even if you don't know where it is, you have this hope of finding it. Whereas if you don't have a tile or something, to add to your keys, you're pretty much like SOL. Like you have to like hunt, you have to try to reset. Because the amount of times I've lost my keys at my house because I just throw them somewhere and then I can't find those, so then I have to go hunt for the spares that I can't find. Causes a whole issue. Whereas like if you lose your phone, all that like is awful. Like worst case scenario, like I'm sure it would be like an app thing. You could always sign in on someone else's and still access your car. But it's not ideal. But at least you don't have to call AAA. You could find out if you have someone else with a phone.
So you have more of a chance if you're not using some sort of secondary app like Tile to find your phone using what's already built in. Other opinions? Other thoughts? Yes, Jess.
I think there's a possibility that like the device might not work. So then you're like sitting in front of your car and you can't get your phone to work to unlock your car. You don't have your keys, so then you're just kind of stuck.
Yeah, I just got the latest iOS updates, and all of a sudden my car key doesn't work anymore. That's true. Yes.
what if your phone does?
Yeah, that's good. That's also a good point. I mean, I think on a daily basis, how many of you? One thing I want to ask this question: how many of you have any stress put into your lives on a daily basis, wondering if you're going to run out of charge? I do. I use an iPhone 6 that's ready to die, and so that's a regular part of my daily stress. My cheapness in not buying a new phone is giving me daily stress. If I were relying on this product for my car key, I know to go back, I'd probably be investing more quickly in a newer phone because I need it. Other thoughts? I think, yeah, please.
There's also a possibility for like, obviously it's not unlimited given like these big corporations cost big money and stuff. There's also obviously the possibility that like somebody associates your device with your car with their device and then you don't have a car anymore.
I mean, the idea of car hacking is already real anyway. I don't know if you guys remember this, but a few years ago when Jeep reintroduced the Cherokee, the reason they were so slow to hit the market, they had two problems. One was the transmission needed to be reprogrammed, and the other was hackers showed how easy it was to use a basic Wi-Fi network to hack into the car and lock the doors from the outside. So you could actually trap someone in the car. Yes?
I think another thing that's changing because like I've seen like even on Teslas, and I know with the enterprise rent a car here, Russ like had to all sign up to get them, and they send us like you don't get a key, you get a like a credit card, and you just tap it against the door and it'll unlock it. So I think keys are going to change from like I can see like a fix would be like even if you lost your phone, like I know with Teslas like you tap your wallet or your card against the door and it unlocks. So like and I think what they're going for is like more like compact, like not because like carrying a whole key around while it's not inconvenient, it takes up pocket space. Whereas if you're already putting something in, you already carry a wallet around with you, or you have your phone sleeve, whatever. It's just another like thing you add to it. So even if your phone's dead, you tap your card against your door you get in, you plug your phone in. So I think there's ways. I feel like if they're going to do that, they're already thinking about these and they're going to adapt the whole. I feel like keys in itself are going to change within the next 10 years.
I've actually got a fail-safe in my key fob that if the battery in the fob dies, there is a key you can pull out of it. And actually, do you have the same with yours?
And then like if the key fob died, I don't know if yours, but you either like mine has a place to insert the whole fob to start the car.
Yeah.
Use it via the chip then.
Yep. Same deal. And it's a traditional key to open the door. You can insert the fob in to get the ignition started. But it's pretty interesting. It's also pretty interesting, of course, the conversation to think that really terrible rental car that we have on campus has the same technology to get into it as a Tesla does. That's pretty wild. Anybody ever used that car before? It is like basic transportation in its most basic sense. Like if somebody stole that car, you'd feel bad for the thief. It's a terrible car. It's an awful car. But keep your eye on this stuff, guys. I know we went a little while on this, but this is the stuff that's going to be changing our daily lives. So I appreciate you being willing to take the time to talk about it. Guys, a little bit of a preface, because what we're getting into today, a lot of this stuff maybe can seem a little dry because it's very much numerical and it's informational. We're going to try to make it relevant as we talk. But some of it just is data because we need to discuss it. I'm not going to spend a lot of time on the inner merits of IP networking, other than to say right now we are in version 6 of the Internet Protocol, and every time the IP protocol has been revised, we've made it bigger and bigger, more digits, more bits total. So right now we're at IPv6, and that means we can have up to 1 quadrillion addresses. You may say to yourself, will we ever use that? Well, probably not in the course of our human lifetime anyway. But the reason we did this, when IPv4 was out, we were running out of addresses. Anybody have a guess, too, by the way? There was an entertainment company that came out whenever we first came out with IP networking that bought almost all the available public IP addresses. Any guesses? It's a good guess. It's actually a company that predates Netflix. Give you a hint, they're a competitor to Netflix. Any guesses? Yes. Good guesses. It was actually Disney. Disney saw the future of the internet, and whenever IP networking really came into the mainstream and the blocks of IP addresses went up, Disney was one of the first companies to heavily invest. They were also, by the way, one of the first companies to use the internet to market to children, too, pluses and minuses. The bottom line is we have a lot right now of potential IP addresses and lots of ways to handle this stuff. To give you a very basic explanation for how IP networking works, TCP/IP over IP networks. Basically, we take information, we are breaking that into smaller chunks we call packets. Routers take those and send them over the internet and reassemble them in the right order. Again, the whole purpose of Transmit Control Protocol, what that means is we need to reassemble the packets in the same order in which we transmitted them. That's why it's a truly digital technology. If I ask you on an exam, what does a router do? And one of the options was a router reassembles packets in the right order. That would be the right answer. And in fact, the EIR that we had in class, well, we didn't have in this class, but we had on campus last week, worked for Cisco Systems, one of the companies that really pioneered routers on the internet. This is where it really gets interesting, though, for our purposes, guys. If I want a pair of Nikes, where do I go? We're online. Nike.com. If I want to go and buy a bunch of books and maybe even some new action figures for my office, where do I go? Amazon.com. Instead of having to remember 124.426.28.12, all I have to remember is this, and remember to reinstall this recording program before the next class. But it really was a game changer. So domain names basically meant we could automatically associate an IP address with written language. It's easier to market, easier to promote. And so this was made possible through something we call the DNS. That's a domain name system. All that means is anywhere in the world, if I enter in google.com, a series of networks will take me to the right IP address to get there. And what we have in terms of an entire web address, we call it a URL, Uniform Resource Locator. The parts of this address are important, though. Right now, your entire URL is this entire address. The domain is only the part that identifies with the brand. So if we were going to http://www.nike.com, the domain is simply Nike. So that's the difference between a URL and a domain name. Although it's really funny when we think about it, it takes more time to say www than it does to say World Wide Web. So it's quicker to say World Wide Web than www. Remember that next time you're giving somebody a web address. Guys, all this stuff plays into something we call client-server computing. And here's where it comes from. We talked before. By the way, anybody remember I told you the name of IBM's first mainframe? What was it called? Big Blue. Big Blue is the first big mainframe. And so we used mainframes back in the day to centralize computing capability. We still use client-server computing. That's why things like smartphones and tablets work so well, because we're centralizing resources in a given area. area. We use it, for example, if we want to put files in a central repository. We can have software live in the middle of the network. And if you want to know, for example, why we centralize all our printers, how we do, it's because we use client-server computing. That is the part and parcel to how modern networks set up. And it's why we're able to have mobile work so well. Don't get me wrong, the processor in your iPhones is pretty powerful for the size of it, but it's nowhere near as powerful as the centralized computing that it's accessing. So guys, if you wanted to answer the question, what makes mobile devices work so well, it's the fact that we've got strong mobile networks, we've got big pipelines that are allowing us to wirelessly connect to them, and strong centralized capability. Let's think about this for a second. If we were able to make all of our phones more powerful, or if we can make a central repository of computing more powerful, which is easier to maintain? We've got literally millions of smartphones and probably hundreds of servers in our company. Which is easier to maintain? If we had to add capability to one, centralized is better. We go to one spot and we bulk that up. We make that computing more powerful. That's why this stuff works, guys. In terms of how this has been a disruptive technology too, we're living what's been referred to some folks as the post-personal computer era, the post-PC era. Think about it, guys. Even though we use computers in class and use them for complex computations, spreadsheets, all these things, our daily internet use, if I monitored you by hour, I would guarantee that most of you use your smartphones or your tablets, most likely your smartphones, more than you use your laptops. Am I right or wrong? Yeah, and think about how most people access the internet. It has changed everything, guys. And in addition to the cloud changing those kinds of services, it's really changed the way we do computing. It was very common, as recently as the early 2000s, for companies to always concentrate on upgrading their internal infrastructure. We need to increase our servers. We need to get more internal computing capability. More and more companies are saying we don't need to do that anymore because we can sub it out. We can use what we refer to as infrastructure as a service. If you go to SCOTUS Hall, for example, the basement of SCOTUS Hall has most of the servers for St. Francis University. Some of them are also located in the library. They have to be maintained by people. They have to be put in air-conditioned rooms. They have to, in really well-run networks, have what we refer to as drop floors or drop ceilings, so you can get in and do wiring. You've got large racks of capability. Well, instead of doing all that, why not just put all your money into a faster internet connection and let somebody else maintain the infrastructure? We call that infrastructure as a service. Software as a service simply means, why does it have to live on my computer? How many of you have ever used a Chromebook? What is unique for those who haven't used Chromebooks? Hunter, what's unique about Chromebooks? There's next to nothing on that thing because it's essentially a web browser. So you're using all your software as a service. I would go as far as saying that Chromebooks represent a platform as a service as well, because you've got some physical infrastructure, but you really have nothing tied to it without the internet. So again, guys, without the cloud, Chromebooks wouldn't work. Why? What's the advantage to a Chromebook? If all that stuff is resident in the cloud, Jill, what's the advantage?
They're cheap, and if you're like not doing anything too heavy with like computing power, they're really good for that.
Yeah.
If you like Chrome OS, they use that. So.
You definitely have to like Chrome, but it comes down to you don't have any hardware to maintain. You don't have to worry about viruses. Basically, I shouldn't say that. Somebody will find an exploit that does something to hardware at some point, but really, it's not a big deal. And anytime we use the term cloud, all we mean is on the internet. It's such a big buzzword. Now, some of the big drawbacks to using this model, obviously, if you get disconnected, sometimes you have very little to go on. It's just like when we find ourselves out of coverage in our cell phones. It also means you're trusting somebody else with your data. Some companies still maintain very vast and intense private networks because they want to do this with their information. If you're using Amazon Web Services, you're using Google, or using GoDaddy's hosting, at some level you're trusting them with your information. So there's a security risk. Another part of it too, you have very little control. How many of you have ever, don't worry if it's a very small number, I'm just curious, how many of you have ever built your own web server? If you, what operating system do you use?
I use like an AWS instance, which I think it uses Linux.
Okay, so So Linux-based Amazon Web Services, yes? Anybody here ever worked with Apache or any of the other kinds of free services that are available? You can customize. You can make that however you want. You've got control over it. If you want to put all your databases and your front end and your media servers on the same box, that's your choice. If you're using it as a subcontracted model, you're giving up some of that power. But the bottom line is it's less expensive to have somebody else maintain it, but you've got a monthly payment on it. Think of it like this. The difference between buying a CD or going to Spotify. Spotify, you'll have your music so long as you're paying for the subscription. So, guys, in terms of showing you how stuff has changed, this is going back about 6 years. We'll show you a 5-year span because the most recent Q data is from 2019. You can read the stats for yourselves. Even as far back as 2014, almost 60% of the population had a smartphone. So we're moving into the iPhone and Google era. And at the same time, we had a lot of folks who were using things like e-readers. We go as recently as last summer. We're up to the point now where almost over 8 out of 10 people in the United States have a smartphone. In fact, the global statistics back up. More people in the world have smartphones than running water. More people in the world also have Facebook than running water, too. So it comes down to the idea this is no longer even a question that we are a mobile society. We're all online all the time. Some of the other trends that are pulling this, guys, BYOB is fun. BYOD. I like BYOB better. BYOD means bring your own device to work, and it's a new thing. Guys, why is that a concern to companies, however? Yes?
It's not their device, so they really have, other than like using the Wi-Fi and saying you shouldn't like Google these things, they can't take it away from you. They can't physically take it away from you. They can't like tell you what applications you're allowed or not allowed to have pre-downloaded. They're not allowed to tell you what you can and can't store on there. If you leave that company, they can't take it from you. Everything you have on there is yours. So while it's convenient for them to not have to purchase one, in the long run it's more inconvenient because if there's an issue with it, it's on you to get it fixed. Everyone has different devices, operating systems, levels of what updates they're on. So for the IT people, that's even harder.
Great analysis. Like Bryce and I work for the same company. He's very conscientious. His smartphone's up to the latest version of OS. All the security exploits have been solved. I haven't upgraded my iPhone in 2 years, and all of a sudden I'm on the same network he is, and I'm making the company more vulnerable by my presence on it. And we've talked a lot, especially today, about the idea that we're getting away from the idea of physical media, and we're putting more and more of our devices, even our cars, online, guys. So this is really changing the way we do things. In terms of some of the utility protocols you need to be aware of, we've talked about hypertext. We've talked about, for example, email. There are companies that use various email standards, yet we can all talk to each other because they're standards. It just means how you're managing your email server. At some point during the class, probably the next class or two, I'll do a little ping and trace route demo for you guys as well, so you can see how we can track traffic over the internet as well. But just know that those are utility programs that are out there. Before we get into some of the more the bigger discussions about the infrastructure, I'd like to pause for a question or comment. We're covering a lot of ground today. Any questions or comments so far? Yes, sir.
I don't know if we're talking about it, but math tape, how come the school haven't has like strict math tape and
I'm sorry, I was having a hard time.
math tape?
I'm not familiar with that term.
Well, top to Xbox, and on there it's strict. And like some games, if you can't play with friends unless it's open. So like I was just sitting there for a minute talking about math tape.
No, that's honestly because I'm not a gamer. I need to apparently get.
I didn't know if it was like on PCs and laptops too.
I can't give you a lot of answers in terms of how they're handling security on this network. I would suspect just from my relationship with the previous administrator, I don't know what they're doing now, they were monitoring traffic, but it was mostly the idea of monitoring packet services for things like Netflix because they were concerned about slowing down the network. So I honestly don't know what kinds of restrictions they're running on those kinds of apps. I wish I had a good answer for you. I could find out. So it'd actually be interesting to know that. In terms of, if you go by percentages, what percent of the student body who lives on campus you think is actively using online gaming?
I'd say at least 50.
Wow, it's that high, huh?
I think a lot of people like
Is it more Xbox or more PlayStation?
I think 50-50 maybe.
You gotta understand, man, my gaming goes back to the old days. I haven't been a serious gamer since Sega Genesis, so I'd love to get back into it. Give me some time on my schedule, I'll be there. But no, I'd like to find that out. Yeah, ask that question again if I don't give you an answer. Other questions or thoughts, guys? And I'm not a network security expert, but I'll try to get some answers for you. Guys, in terms of some of the other things that have been going on right now, the companies that provide us internet service are really significantly putting money into infrastructure. And the reason being, things that are coming down the pike right now, how many of you, does anybody live in a metro area where you have access to fiber for your internet? For example, we call it Fios at Verizon and something. The bottom line is we have a lot of dark fiber in this country, and fiber is de facto the fastest internet traffic you can get because you're traveling literally at the speed of light. It's got almost limitless capacity. Throughout the country, there's lots of stuff called dark fiber, and that just simply means back in the 90s when all these companies were expanding, they put fiber optics in the ground when the dot-com bust came back. We call it dark fiber because it was never lit up. There's still plenty of it in the United States. So why have we been doing so well? Well, we've got adaptive technologies. TCP/IP networking, although it's got some overhead, is pretty adaptable. And we're going to talk about what we refer to as the hourglass model. Guys, this is right out of our text. We talked about the different layers of networking. One of the biggest limitations we've had and continue to have, particularly in rural areas, is physical infrastructure. Right now, let's compare two areas. You've got Pittsburgh, Pennsylvania, you got Loretto. You're a telecom provider. Where are you going to invest upgrades in infrastructure and why? It's 2020. Where are you going to put your money? I completely agree. And why is that? Growing population, demand for services. This is a population that is never going to actively exceed where we are right now, and it's a seasonal population. If you want to know why rural areas have been the last to get things like good cellular service, it's strictly a matter of dollars and cents. That's why some people in rural areas are limited to satellite internet. That's why people in rural areas do not have access en masse to things like fiber optics. It's the first layer of networking. Layer two, when we get into our IP networking, for example, that's where we start to get a little bit of a squeeze. And what I mean by that is the more protocols, the more information we put into our networks, the more things can't slow down. When we get up to layer three, anytime we get into things like security and authentication, they make our communications more secure, but they also eat up bandwidth. And finally, layer four, in terms of how well these things work, such as web browsers, email, anything that requires bandwidth, it's weighed down by all these other things. So by the time we get to layer four, it's limited by the other areas. In terms of how physical infrastructure works, guys, right now, for example, I mentioned that there's a school in Pittsburgh that has a direct connection to the internet. Who is it? Big school? Carnegie Mellon. They're what we refer to as a regional hub. So they tie literally into the backbone of the internet. Here's where all this stuff is connected, guys. I was talking with my Batman class this morning. We were talking about the aftermath of the 9/11 attacks. In 9/11, when that event happened, most people on the East Coast lost telephone service and internet connectivity, even though we were nowhere near New York. And the reason being is major lines go through New York City because it is the most populated city in the United States. A lot of technology companies are based there. In addition to the fact that our connections to Europe come from New York City. That's where a lot of that stuff comes from. So if you got a major hub, that's gone out to regional hosts. So for example, I've got Atlantic Broadband as my provider in Altoona. Yours might be Verizon. These regional hosts still go back to the hubs of places like Carnegie Mellon. They're still getting all their stuff from different places. For example, we've got a regional host that could be somebody like Atlantic Broadband, taking it back to my house. I happen to have cable internet. I have decent service. I redistribute it in my house through Wi-Fi. If we go over to a more corporate type setting, don't get too hung up in the technology. For example, the old lines, the dedicated internet connections were called T1s, and that might take us to what we refer to as a campus area network, and we provide internet to the entire campus here at St. Francis. If we have an office network, we could also call that a campus area network. So we still are always going back to the backbone. Here's the analogy, guys. Right now, if we're using a wireless internet connection, what's our top speeds on wireless at this point? If we just go strictly by internet, not internet speed, but my network speed. Yeah. 45 megs. Yeah, and if we go back to the old 802.11 standards, way back when, they were anywhere between 10 megs up to an ideal of 45 to 50 megs. That's not the true limitation. The limitation of your connection speed is based on what your external connection is. So if our external connection to the internet for this campus is 1 gigabit, that means we've got 1 gigabit to redistribute to everybody who's on the network at any given time. So even if we have true gigabit Ethernet, gigabit networking to our desktops, we are still limited to whatever comes into the campus. Think of the analogy like this. It does not matter how big the pipe is in your house. It matters how much water is coming into that pipe. That's going to determine the pressure and the size of the pipe too. But a big pipe with nothing in it still means nothing. Yes?
Isn't 4G 4 megabits and 5G gigabyte? Is that what it is?
That's what they're promising. But I mean, we'll see if we actually get it. It's also based on demand. If you guys, I don't know how many of you, because none of us ever read the terms and conditions. Next time you see a big advertisement for Atlantic Broadband or for Fios or anything, and they say about their amazing download speeds, it says right on the bottom of the screen, download speed not guaranteed. Would we? Yes. Would we accept that and anything else? This car will do 0 to 60 in 5 seconds, and on the bottom of the screen, this car may not do 0 to 60 in 5 seconds. Nobody would buy that car. We accept that level of ambiguity in these services because they're all based on demand. So I think it's fascinating how this stuff has grown around. But in terms of the way this stuff all puts together, guys, we've got what we refer to as Tier 1 services, and those are big ISPs. Just remember that, guys. The CMUs of the world are Tier 1 types of services, people who have direct connections to the internet. And again, we're going to talk about what some of these interfaces look like. Between us and Europe, we still have miles and miles and miles of fiber optic cable, physical cable connecting us, because fiber, is still faster at this point than wireless. So fiber is the fastest connection you can currently get. So in terms of all this stuff goes together, I'm not going to spend a lot of time on telling you about how this works in the bigger picture, because then we get into really a class about telecommunications providers. The bottom line is that we're seeing major interconnects mostly at major cities. Now, when you get out to retail providers, this is where it gets interesting, though. Interesting for us because we live in these kinds of areas. Companies like Verizon, whether it's Comcast, whether it is this really annoying message that keeps on popping up on my screen, people are reselling smaller versions of internet connectivity once this stuff comes to a regional area. How many of you have ever lived in the world of dial-up? It's a painful memory. It's like you feel like you should talk to somebody about the days when it took 10 minutes to download a pirated song. I still have nightmares about it sometimes. But we refer to that as narrowband. If it's less than 56 kilobits per second, this one I would write down. If it's less than 56 kilobits per second, it's narrowband. If it gets above 56K, we generally refer to it as broadband. Broadband can be satellite, it can be DSL, it can be cable, it can be anything that gets us past the 56 kilobit mark. 56 kilobit was the limitation of what we had in our telecommunications infrastructure. And by the way, guys, I am going to go off on something for 1 second here. Literally, when we think about what makes a computer network, if you're physically plugged into a network, what element is data traveling across? Physically plugging into an Ethernet jack here on campus. It's a metal. It's copper. Anytime you run current through metal over a period of time, it degrades. Whether it becomes less magnetic, it becomes less conductive. For the same reason that, for example, a battery wears out because you're wearing out its elements, the conductivity of metal wears out over time. The infrastructure that we have in this region of the country is among the oldest in the nation. So we literally, physically, through things like DSL, cannot get the same speeds that people in other places can get because our infrastructure is old. So That's literally some of the connectivity problems we have. That's why you replace cabling in buildings. That's why you make it and upgrade it. In terms of how all this stuff works, guys, we still have in this country two basic types of internet access. We've got folks who access over telephones, which I count smartphones in that as well. But we've got folks who are still paying for, who are paying for broadband at home. We're using computer-based. In terms of where we're heading with 5G, the providers like Verizon are promising us up to 10 gigs. I think your estimate of 4 is going to be lucky if we get it. And we're still going to be sharing the same pipeline when we get there. So I do want to make, actually, we're talking a lot of statements. We're going to take one more break before we get into a couple of factors about 802.11, which is important for you guys. Questions or comments before we jump into the fine world of wireless networks? This is a little trivia question for you guys. Okay, the original wireless networks, 802.11b, you don't have to write this down. This is just a trivia question. Operated at 2.4 gigahertz. Another very ubiquitous device in your homes that involves radiation also operates at 2.4 gigahertz. What is it? It is a microwave. Do you know why microwaves operate at 2.4 gigahertz? It is the most effective frequency for boiling water because water is very conductive to electricity at that frequency. Let's think about that for a second. Most of the wireless networks that we have at this point in time are designed to insert radiation into water. What is the human body made of? 75%. We are walking conductors for radiation. I'm not here to tell you that this access point is giving you cancer. I don't mean to say that. I do mean to say that if we fill this room with more people, your connection, even if you can't notice it, probably does degrade because the radiation coming out of that access point is getting absorbed into our bodies at the same time. So it's a pretty interesting factoid that what was designed to boil water now gives us connection to the internet. So a little factoid for you. Don't let that keep you up. But the low power of these things. Now, if we're operating next to like large wireless transmitters, people have justifiable reason to be concerned about that. This high wattage, that's stuff that can cause us problems. Wi-Fi, however, which stands for wireless fidelity, and what that means is we have networks that can operate without cable. That may seem ubiquitous to you guys because you don't remember the pre-wireless era. I can't tell you how awesome it was the first time I had a laptop with a wireless card. It seemed like science fiction. It was unbelievable that it worked so well. Wireless fidelity, Wi-Fi is also referred to as license-free network. Here's the difference. If I want to set up my own radio station and broadcast all over the world using high power, I have to get a license for it from the FCC. This is license-free because it operates on low power, meaning all of us can have Wi-Fi devices. We're operating the same spectrum, and we can operate without interfering with each other. But if more of us get on, it does degrade the connection. Then we're moving on to things like Wi-Fi or WiMAX, which is going to be used for infrastructure, and Bluetooth. Infrastructure meaning backbones. So in terms of the way all this stuff works, again, guys, you're very familiar with Wi-Fi because we use it every day for just about everything. And your Wi-Fi connection is not probably the reason your connection at your laptop is so slow. It really does come down to the idea of what is your backbone communicating on. Now, some companies are trying some really cool things with ways to make wireless available to more people. And given the time we're at today, we're going to start off here on Wednesday talking about Google and Project Loon. Guys, we're almost out of the theoretical part of the course. So thank you. I'll see you on Wednesday.